Hello.
Hello.
What happened today? Hello, Eric. Hello, Ryan. How are you today? Yeah, you seem not quite upbeat. Okay. So remember, we talk about the happy numbers. Yeah. Can you remind me what's happy numbers?
You just square up the digits
And then
until you get one.
Until you get one. If it's get one, it's a happy number. Yeah.
Yeah.
Okay. So today we're going to talk about another number called ugly number.
Ugly.
You know what's
Ew.
ugly?
Ew.
What's ugly?
Is the opposite of beautiful.
Yeah. Okay. Ugly number.
Ugly number.
So what's ugly number? Like if a number has prime factors of 2, 3, and 5 only, they're ugly. For example, like 2, 4, A, 16. It has only 2, then it's ugly. 3, 9, 27. Yeah, these are ugly. Or 5, 25, 125, ugly. But you also 6 is also ugly, right? Because 6 equals 2 times 3, and it's ugly. Yeah, only has 2, 3, or 5. Also, so for example, like 30 equals 2 times 3 times 5. Okay, ugly. Yeah, but if that.
It's just like okay.
So look, if 210 is not, why? Because 2 times 3 times 5 times 7, it has 7, which is not included in the list, right? So it's not ugly, okay? So if a number is prime factors, it's factors. If you can express an integer as 2 times A times 3 times B times 5 times C, yeah? If it is in this format, it's an ugly number. A could be bigger or 0, equal to 0, and B also, C also.
I'm a beautiful one.
Yeah, for example, like 20, is that an ugly number? It's 2 to the power of 2, 2 times 2 times 5. Yes, because it only has 2 and 5. Right? Okay, let's see. 36 is a ugly number. Look, we can try with the smallest 2, right?
No.
2 times what? 2 times 3 times 3, yeah? It has only 2 and 3, right? So it's ugly. Okay, let's see another one. 49.
Yes. No.
No, because it's 7 times 7. It's not, right? Yeah?
So you just using the same number times thing.
So if you're finding the factors, you can actually any integer you can express as these kind of express as the prime. These are prime numbers, yes? Yeah? Any integer you can express as prime numbers. 7D, and the next prime number is 11E, right? Yeah. So it could be, this is multiplier. It could be any integer could be expressed as the prime numbers powers times together, right? For example, given a number like you say the number.
What?
Any number.
Why?
Just pick a number. Come on, Ryan.
109.
109. Okay, is that a prime number? Oh, this number is too difficult, right? Pick another one. I don't know if it's a prime number. If it's a prime number, then it's 109 to the power of 1, right? Obviously, right?
Yes.
Okay.
So it's ugly.
It's not, because it doesn't have 2, 3, 5. Only if it's 2, 3, 5, then it's an ugly number, okay?
Only it has one of those.
Or mix, it doesn't have anything else, right? Okay, so any number, pick a smaller number, right? Or you, smaller number.
25.
25. 5 times 5. Okay, so it's 5 to the power of 2, right? Look, this is the prime number, yeah? Or any number, again.
7.
7 is a prime number, yeah, 7. Like another one, 28, okay? 28. 28 is 2 to the power of 2. Yeah, this is a good example. Times 7 to the power of 1, right? This is prime number, this is prime number. You see, you can express as the prime numbers to the power times together. and this has factor 2 and 7. So this is not an ugly number because it has 7. Okay? Yes? Got it?
Yeah.
So how can we check if the prime number is a prime number? What's the strategy? What's the strategy? Any strategy is how we check if the prime number is a
Whoa. It has to be odd.
It has to be odd?
Or prime numbers are odd except from 2.
Okay. But, and then what?
Wait,
No, that's
it only can go, I don't know how to explain.
Okay, that's fine. So how about we try to divide the 2, 3, and 5, right? Yeah? As much as we can until we count. And then if the remaining integer is 1, it's an ugly number, right? If it's not 1, it's not an ugly number, alright? Yes?
Yeah.
Look, for example, 28. We divide it by 2. 14 divided by 2, 7. Can we divide it by 3? No. Can we divide it by 5? No. And then the remaining is not 1, then it's not an ugly number. How about 25? Can't divide it by 2, can't divide it by 3.
5.
Can I divide it by 5? Yes.
Yeah.
And can I again divide it by 5? Yeah. And then it's 1, it's an ugly number. Yeah? Yeah? You see this strategy? Sorry?
Why is it 1?
So, because we are checking if the number has the only 2, 3, 5, these 3 prime factors, so we can keep dividing it, right? Yes, because we are looking for this 2 to the power of A times 3 to the power of B times 5 to the power of C. Yeah, if it's an ugly number, it should be least. Yeah, n equals that. So look, and we can times something else, something like A, big A, right? So look, if we keep dividing by 2, by dividing by 3, by dividing 5, and if the remaining is 1, it's an ugly number. If it's not, right? If this is 7 or 11, it's not an ugly number, alright? Do you get it?
Oh yeah.
Yeah? Yeah? Okay, so you tell me what to do, okay? Define ugly
Oh no.
n.
Yeah.
So look, if n is smaller or equal to 0, we return what? Return false, right? Because it's not a ugly number, yeah? Because 0 is not, right? And my negative is not, okay? So look, we can do this while n can be divided by 2, yeah? Can divide by 2. This is n can be divided by 2. Then what do we do? We keep dividing by 2, right?
Yeah.
So n what, Eric?
N
Divided
by 2
equal what?
2.
Okay, and then while n 3
equals 0.
and
N divided by equals 3.
and then while
N divided by 5 equals 0. N divided by equals 5.
okay, and return what? Return what? Return what? You guess.
Ooh.
And here is missing column. Yeah. Return what? Remember, we divide it until it become. We can't divide it, then we need to check if n equals to what. Then it's an ugly number.
1.
Yeah. Return n equal 1. Yeah.
Yeah.
Yeah. So look, this is the kind of duplicate. We can do this in one go. Much simpler way. So 4.
You have so much
Look,
space.
P in what? In 2, 3, 5. Yeah. This is a list. Yes. Yes.
Yeah.
Yes. While
Where's P from?
P will be 2, 3, 5. So this is iterative. Yeah. Because this is a list. For P in this list, it means the P will be equals to 2. Do this. P will be equals to 3. Do this. P will be equals to 5. Do this. Yeah. This is a loop. Okay. While n bigger than 1 and n can be divided by P, yeah? And then, can you tell me what should I do here? N what? If it can be divided by P, and what should I do? I divide it by P, yeah? N divided equals
P.
Yeah, and then that's it, and then return and equals 1. Yeah? Got it?
Yeah.
Okay, so that's it. Today will be just a simple math. Okay, so any questions before I erase any of them and then yeah? Okay, so close your eyes. I'm going to erase it. Okay, close your eyes. Close your eyes. Okay, that's it.
What the flip?
Okay. Yeah.
While something.
Yeah, why or something? Yeah, come on.
While.
Okay, write it properly. While, yes. Okay. While what? While we need to check if y we can divide it by p, right? P will be 2, 3, and 5.
While P. No.
No. While n will be equal to
N.
bigger than 1. When bigger than 1, because if it's 1, if it's less than 1, we don't need to continue to check, right?
While n bigger than 1.
And
And
what? We're checking if this number n can be divided by p, right? So how do we do this?
and
If n can be divided by p.
if.
Why? No if. N, y n equals 1 and 1 y n can be divided by p. How do you check if it can be divided by p? How do you check the remainders? No, this is to divide it, but we want to check if it can be divided. Modulus, yes. Modulus, yes. Well done. And the modulus what?
P.
Yeah, and then modulus p equals what? Equals 2 equals 0, yes.
No.
Well done. Yeah. That's it. That's it for today. So good job today. Can you say bye bye to people?
Bye.
Good job.
Bye.